Welcome to Ask and Learn.
Okay, so this problem talks about the rooted Fibonacci trees Tn, such that T1 and T2 are both rooted with a single vertex. T3 and higher is going to be based off the left subtree is Tn minus 1, the right's going to be Tn minus 2. And so it's asking us to find the series for the vertices, leaves, internal vertices, and for the height. So let's go ahead and take a look. I already have these already drawn out. And so now all we have to do is fill in the values. So for the vertices, we know that T1 and T2 are single, so they're going to be 1. If we go up to T3, we can count that there are 1, 2, 3 vertices. T4 has 1, 2, 3, 4, 5. So 3 and 5. And I'm only going to go up to T5 because the fact that we can get the sequence from there. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's a total of 9 vertices. So let's go through and see if we can figure out how these are related. So typical Fibonacci goes back to the previous 1 or 2, but since we're using left and right, if we look at T3, we have 3. So if we could take T1 plus T2, and then we could add 1. So let's see if that holds for T4. So if we were to add T2 and T3, that gives us 4. So plus 1 would be 5. And then if we look at T3 plus T4 for the T5's vertices, that gives us 3 plus 5, which is 8, and then plus 1. So for this one, we have that A1 equals 0, A2 equals 0, but AN is going to equal AN minus 1 plus AN minus 2 plus 1. And that's our answer for the vertices. So then if we go down to the leaves, so we know T1 and T2 had 1 leaf each because they're single vertices. So they had 1 each. If we go up to T3, there's 1, 2 leaves. Remember, leaves are the ones that do not have children. T4 has 1, 2, 3. So 2 and then 3. And then if we go up to T5, we have 1, 2, 3, 4, 5. So let's look at the pattern for these. So let's start off with T3. And so if we do this one, this would be just T1 plus T2. T4, does T2 plus T3 hold? So 1 plus 2 is 3. That holds. And then for T5, we have T3 plus T4, and 2 plus 3 is 5, so this works. So for leaves, it's going to be B1 equals 1, which also equals B2. Bn is just going to be Bn minus 1 plus Bn minus 2. Okay, so for internal vertices, what I can do for this one is I can just add and subtract my vertices. I can add my vertices and my total vertices for my leaf. So T1, I've got 1, and I've got 1 leaf, so which means internal-wise I have to have 0. And the same thing is going to be for T2. For T3, my total is 3, and I have 2 leaves, which means I have 1 internal vertice. For T4, I've got 5 total. Subtract the 3 leaves, and I have 2 vertices. So total for T5 is 9, and I have 5 leaves, which means I have 4 internal vertices. So if I look at the pattern here, so for T3, it would be T1 plus T2 plus 1. So let's see if this holds for all of them. So T2 plus T3, which is 1, plus another one would be 2. And then T3, which is 2, plus T4, which is 4. Oh, no, I'm sorry. T3 is 1, T4 is 2, so that's 3, plus the 1 is 4. So this would be C1 equals C2, which is 0. And Cn is going to equal Cn minus 1 plus Cn minus 2 plus 1. And then last but not least, we want to figure out the heights. So T1's height is obviously going to be 0 because it is, and T2 because they're just single vertices. If we look at T3, we have the 0 level and then we have the 1. So this height is going to be 1. If we go up to T4, this one has the 0 level, 1, 2. So that one's going to have a height of 2. And then T5, we have the 0, 1, 2, 3 level. So T4 has a height of 2, and T5 has a level of 3. So if we look at this, this one is just going to be n minus 2.